Hello, I'm Dennis Thomas, president of JND Thomas Company. We're here in Westlake, California, right next to Thousand Oaks, California, which is basically about an hour and 15 minutes from LA. We're a dredging contractor that has been contracted by WILMA, which is Westlake Management Association, to dredge approximately 88,000 yards of in-situ material from their 128-acre lake. The lake has basically about 1,700 homes, each of them having a backyard to the lake and a dock. We had a lot of issues to deal with in doing this project, and one of the first ones was the boat traffic. We were able to handle the boat traffic by submerging our line. One of the other issues has been the noise, and probably one of the best things we did there was to sound continuate all of our equipment, all the diesel engines. There's 4 diesel engines. All of them are have enclosures that muffle the sound. When you're out on the project, you're going to hear people mowing lawns over our equipment. So it's very, very, very quiet, which was a very plus for the people here, because they live here and they wanted their lake dredged, but they did not want to be disturbed.
I'm Brian Reed, and I'm with Pacific Advanced Civil Engineering. We go by PACE for short, and I'm the resident engineer on the project. And we're here representing WILMA, Westlake Lake Management Association, on the dredging, and we determine volumes and oversee the contract of the dredging. Once we got going, JND did a great job, being proactive, jumping on the site. Actually started a little bit early, mobilizing in, kind of at their risk, which was great, active getting the job going. So we let JND know that we're going to be using electronic data. We'll be sounding the lake and collecting data with the GPS and determining volumes off of that, and that it would be beneficial to both of us if JND could incorporate an electronic system onto their dredge. We also looked at their dewatering process was key, because it was a small footprint and low impact to the environment. This is kind of a nice area here, and people are sensitive to noise and the impact of everything. One of the things that made JND stand out was brand new equipment with very sound efficient. A lot of dampening on it, very good acoustics. As a matter of fact, we've had minimal complaints on noise, and it's really worked out well. And that goes for the dredge as well as the dewatering equipment. Overall, I've been very pleased with the project, and in fact, JND Thomas and PACE are working on a project just a few miles from here in Simi Valley just after this project, and we look forward to working again on that. And it's been great, and I'm sure we'll have another successful job and hopefully more to come.
The other issue that they wanted was they want a very clean operation. Most of my competition on this project were bidding on putting mechanical means. Basically, they were going to use excavators or drag lines and pick the mud up and put it in a barge, and then move it over to a couple of small areas and put it on the bank and dry the material. I chose to go with a hydraulic system, so we employed a moray dredge, which is an 8-inch pump dredge, swinging ladder. We have no cables out in the water, which is another plus because of the boat traffic. We have to be a very tight operation. The swinging ladder will swing 18-foot path. The project we're pumping distance that we've been pumping has been on a maximum of about 6,500 feet. Probably about 60% of the material has been past 5,000 feet. So we had to come up with a system of submerging our pipeline. To have it floating, which is mostly dredging companies would have your line floating so that you have the ability to service your line, we had to submerge it. We submerged the line by weighting it down every 50 to 75 feet with blocks and a chain system. And every 400 feet we put a buoy, and those were our flange systems, so that we put a buoy and a light so that we can mark it, so we have the ability to service the the pipeline in the event we had a problem with it. We used a booster pump that will help keep our production up. The 8-inch dredge will pump about 3,000 feet, then we have an 8-inch booster pump that will pump the other 3,000 feet. We went with a computerized system to monitor the pressure. It automatically will rev up the engine and decrease the RPMs according to the pressure, so we didn't need to have a person on the booster, which made it very automatic. Also, on the dredge itself, we employed a GPS system along with a densiometer, which gave us a percent solids, which was fed into a computer, which gave us our production. Very, very important, because the operator he's out there dredging. He could dredge a lot more material than a dewatering plant could handle. So as we changed from sand to rock to debris to organics to the very fine biosolid type of material, we had to adjust through radio contact with the people at the plant and with the operator to be able to keep the material at a point to where we weren't discharging material back into the lake. The GPS system basically made it very easy. The engineering company put everything on digital, loaded it into our laptop that was on the dredge, and the operator would have his cut lines and fill cut lines right on the laptop that he watched in the machinery itself. So basically, technology has helped ease this project, reduce people, and done a better job for the overall project.
I'm the Lake Operations Manager for Westlake Lake Management Association, and we're here this morning to talk a little bit about JND Thomas, the contractor that we've hired to dredge Westlake Lake. Yeah, when Dennis arrived on location, we had originally chosen a place up on a state highway, but through a lot of controversy about shutting down some lanes on that thoroughfare, we decided to move the operation. JND Thomas had no problem with doing that. We relocated over here close to the office. It actually proved to be a better location. We've had a lot of great cooperation from the city of Westlake and Thousand Oaks for this project. Dennis and JND brought in a lot of new equipment, really the state of the art. I think the operations went very well. We're just cruising right along. The materials changed throughout the course of the dredging operation. JND Thomas had to adjust the polymer rates to give us good return back into the lake, because we have returned the carriage water into the lake, and the process has been very effective. We've removed over 88,000 cubic yards of material. We've opened up a lot more available negotiations for the watercraft, and also we've deepened the lake. Yeah, we had some changes throughout the course, as most projects do. We have several hundred docks out here on private residences, and to remove those docks and disconnect the electrical would have proved to be a quite an expensive task, as well as, like, inevitably somebody will say, well, that's not the way it left, and this is the way you're bringing it back, and it would have been something we'd had to deal with. Well, we decided just to move all the boats with the cooperation of JND Thomas. The Westlake staff moved boats with very short notice, and we got it moved very quickly, moved them back. People really didn't have very much disruption. Also, JND was also requested to keep the channels open for boating, which is very important on a lake like this. People want to be out on it. So we marked a lot of the pipes with flotation and lighting, so in the evening most people could avoid the pipe. We used containment barriers to keep the material in place, so now that we've finished the job, we're going to go in there and remove most of that material. So we're really pleased here with JND Thomas's and their operations here at Westlake Lake.
The dewatering plant is basically a system of different types of equipment to handle different types of material. The area in the lake, areas of sand, areas of rock, areas of organic material, very different. So we have to have a dewatering plant that will handle all those materials and handle them at their peak amounts. So the system had to have a wide range of equipment to handle all the different materials that can be pumped to it. The first system we employed is a set of dual tandem shakers, shell shakers, used in the oil field industry for years, and basically we cut anything larger than 1/4 of an inch, plus all the plastics and cans and debris that gets washed into the lake. the water falls through those 1/4-inch screens down into a tank. From there it's pumped automatically with a float system to two 15-inch cones, low vac hydrocyclones that remove the water by a cyclone vacuum process and discharge the heavy materials onto the King Cobra shakers. These shakers are very fine screen shakers, 210 mesh, which is basically you cannot see through the screens, but it catches all the very fine particles of sand. We wanted to remove the sand at this point to keep it from going into our clarifier and our centrifuge, which are a very wear tolerant. From the cones and the King Cobra shakers, the material then is pumped up to our clarifier. And the clarifier, I felt, was one of the most important pieces of equipment that allowed us to do this job. We had a very limited area. When you're saying your area for putting your plant is 20 feet wide and 300 foot long, that's very limited to try to handle 2,000 gallons a minute of dredged material. With that clarifier, which is basically an 8-foot tank, 8 foot wide, 14 feet high, and 56 foot long, it's a tank with a chain that is dragging on the bottom of the tank and moving material into a cone. As the material is pumped from the cones to the clarifier, we add a polymer, which is a material which will grab to the solids, go around the solids and make them heavy. And as that material gets heavy, it falls to the bottom of the clarifier, then the chain moves it to the cone. You have 2,000 gallons a minute going into the clarifier with about 30%, it was about the max, 30 to 40% of solids. We were able to pump about 30% settled solids to the clarifier. The organics was probably the toughest material to separate in this whole system. So you've got 2,000 gallons a minute with a polymer added, with about 30% of that being solids that are going to the bottom of the clarifier. Once the material was pumped from the bottom of the clarifier, it was ran through 2 centrifuges. These centrifuges are one of the largest couple that are built. There's a ribbon in the inside which allows more volume. Each one was handling between 300 and 350 gallons per minute and discharging solids at a rate of about 60% solids onto a loading belt that was going into the trucks. Basically, the centrifuges did the drying for us. They removed that wet, slurry type of material to a bulky, heavy material so that we could load and process it. All in all, I think we were very successful in bringing a very unique piece of equipment and process to Westlake, considering the requirements, a very small area for dewatering. Our process being less than 6,000 square feet. Our system is on a 20-foot wide by 300-foot long green belt, able to keep traffic open for loading trucks, be able to keep the sidewalk traffic for the people who wanted not to be inconvenienced. We have a lot of boat traffic. Most of the time they're very unobtrusive to them. They've been able to enjoy their lake while we were even dredging and working. Our system has been very quiet. We have sound attenuated all of the diesel engines, the 4 diesel engines that we have on the project. So people aren't hearing us, and basically the affluent area here, this is what they wanted. They wanted a system that could do the work without intruding on their lifestyle. And I think we were very successful in doing that, and I feel they were very pleased with the project.